Welcome to the channel. Raj the physicist, one of the finest platform to learn the concepts of physics. In the last session we have learnt about Maxwell equations. So today we are going to derive an expression for the differential forms of Maxwell equations. To get the differential forms we need to know the previous equations that we already learned in the last class. So first law, that is Gauss law, can be written as surface integral of E dot ds is equals to q by epsilon naught. Here we can write the charge in terms of volume integral rho dv, because the volume charge density rho can be written as q by v. So here we can write nextly, according to Gauss divergence theorem, we can write here surface integral of E dot ds, that is equals to volume integral of divergence of E dv. So here Gauss divergence theorem we are going to use, and it states that the surface integral can be transformed into volume integral. Okay. So the next thing, if we substitute these two things over here in the equation number 1, then we can write volume integral of del dot E dv is equals to volume integral of rho dv, here 1 by epsilon naught remains as it is. So that we can finally write del dot E is equals to rho by epsilon naught. So this is the first differential form, that is the first equation of Gauss law in terms of differential form. So the next thing will be about Gauss law in magnetism. So from the second equation we can write here B dot ds is equals to 0. Here also according to Gauss divergence theorem we can write, according to Gauss divergence theorem we can write here surface integral B dot ds is equals to volume integral del dot B dv. So here if we replace the B dot ds, surface integral B dot ds here with this, then we can write volume integral del dot B dv is equals to 0. That will implies the differential equation del dot B is equals to 0. So this will be the second Maxwell equation in terms of differential form. So now we will derive the remaining two equations. Let us now derive the third Maxwell equation in terms of differential form. To get that we are going to write the third equation, that is the line integral of E dot dl is equals to minus dou phi b upon dou t. So here we can write the phi b as surface integral B dot ds. So according to Stokes theorem, here we can write, according to Stokes theorem we could write here line integral E dot dl can be replaced as the surface integral of curl of the electric field multiplied by here ds. So Stokes theorem states that it can transform the line integral into a surface integral. So that we can write here, replace the term E dot dl as surface integral del cross E ds, that is equals to, here on the right hand side we can write minus dou by dou t of surface integral B dot ds. So if we remove the surface integral from both sides, then we can write del cross E is equals to, here del cross E is equals to minus dou b upon dou t. So this will be the third Maxwell equation in terms of differential form. Similarly we will find out the fourth Maxwell equation in differential form. According to Ampere's law we can write here the line integral B dot dl is equals to mu naught I. So here one important thing we need to know about Ampere's law. Ampere's law modified by Maxwell, because there was something with this current, that is it will be a conduction current, there must be some kind of displacement current. From that we can write the current, that is the total current flowing through the circuit will be equals to, here we can write IC plus ID. So here ID will be the displacement current that we will see in the next topic. Up to now we just derive the equation that will be in the form, let us see here, I can be replaced as the surface integral j dot ds and the b dot dl can be written from the Stokes theorem. So according to Stokes theorem we could write here line integral of b dot dl is equals to surface integral of del cross b dot ds, and I can replace that integral surface integral j dot ds. So we can write here surface integral del cross b ds is equals to mu naught into surface integral j dot ds. So that we can write finally here del cross b is equals to mu naught into j. So this will be the fourth Maxwell equation in terms of differential form. So now I will write here the four equations in differential form. The first equation is del dot E is equals to rho by epsilon naught. Second equation is del dot B is equals to 0, and the third equation that we got here, that is del cross E is equals to minus dou B upon dou T, and the fourth equation is written as del cross B, that is equals to mu naught into J. So these are the four Maxwell equations in terms of differential form. So that is all for today's session. Thank you so much for your time.